Do you want to see how easy organic chemistry can be? Then check this out. Hey, what's going on, everybody? All right, so what we're going to be doing in this video is actually I'm going to give you some examples. I'm going to walk you through how to figure out the formal charges. You remember last time we talked about that we pull these off the periodic table, we look at the electrons, we can figure out the number of bonds, and when we change those number of bonds, that's when we get different charges. So let's start with, let's do HO, N, this, and let me fill everything in here. Okay, I think I got everything. All right, so let's say we're dealing with this structure. Let's say we didn't have to draw it. Let's say our professor just wound up giving us this, okay? And I'm gonna go ahead and write these up here so we can remember. This obviously was 8, 7, 6, 5, 4. Now, like I said, there's two different ways you can do this. You can remember how many bonds you wanna have to each atom for it to be, neutral, positive or negative, or you can just remember that these are the number of electrons, okay? And when we talk about electrons, remember each line counts as one electron, okay? So how are we gonna do this? Now you'll notice here that I did in the last video talk about hydrogen, but I didn't talk about how many bonds are going to be to it. So with hydrogen, it's always going to be one bond, so you're typically never gonna have to worry about figuring out what's the formal charge on that. You just kind of leave that alone, okay? So then what we wanna do is we wanna go to the next one. So if we look here, we look at oxygen, we've got 1, 2, 3, 4, and then 1 for each line, 5, 6. So if we go up here to oxygen, it's 6, so that's going to be neutral. There's no charge on that, okay? Now we're gonna move over here to nitrogen, and we're gonna see here nitrogen, what do we want? We want 5 electrons around it. Now we're gonna see here is we got 1, 2, 3, we only have 4. Remember we said each electron is negative, so if we've removed one, then that means that the nitrogen has to be positively charged, okay? Let's go to this oxygen here. We can see we need a total of 6, 2, 4, 5, 6, that's neutral. Let's go down to this oxygen. You can already see there's a difference. You can see where this is going, but I'm doing it for formality's sake at this point. I know you guys are rock stars at this point in time, or experts. 2, 4, 6, 7, 1 extra, so that's a minus. Now, one thing I also want to point out that you'll notice with this is that with this structure, we have a plus and a minus. So although these charges, most molecules don't want to be charged, they want to be neutral. But if they do have charges, you can see that they're always going to counterbalance each other like that. So we have a plus and a minus, so overall that changes that in kind of quote unquote neutral, but you'll see that we've got that. But that's all we're doing is literally walking through the molecule and figuring out based on electrons, okay? Let's look at another one. Let's see here. Let's do, how about this one? Let's do SO, Cl, Cl. And like I said, I'm not going to worry about us trying to figure out how to build this at this point from a formula. We're just going to put these on here. All right, so let's look at this structure. Now, what we're going to notice here is that the only one that I have drawn on here right now is the oxygen. All these other ones aren't on there. So if you go to their periodic table, where does everybody see chlorines, right? Is that 8, 7, 6, 5, 4? Do you guys get it? Yeah, so this is going to be 7. This is under the halogens. That's kind of a fancy name for those elements, those are halogens. So these are going to be 7. Do you know where this S is, sulfur? Yeah, that's right. It's going to be under oxygen, so it's in the 6. So this is 7 and that's 6. So now what we do is go through once again, and we just start counting electrons. So this was 7 under fluorine, so 2, 4, 6, 1 for line 7. So that's neutral. Obviously, we can mirror this and see that's going to be neutral. What about sulfur? So sulfur was 6. We've got 1, 2, 3, 4, 5. We only have 5 there, so that must mean that that's a plus. And then oxygen, we want 6 as well. And we've got 2, 4, 6, 7. We have 1 extra, so that's going to be a minus there. Okay? Pretty simple, right? Walking through that. We'll do one more example. And then by that time, I know you all will be like super experts here. So let's do this. You guys will be like top of the class, huh? All right, so let's do O, N. Okay. This. Got to make sure I'm doing it correct as well. All right, so let's look at this one. So we said, remember, hydrogen we don't worry about. That's always going to have 1 bond, so we're good with that. Carbon is 4. 1, 2, 3, 4. We're good on that. Oxygen is a total of 6. 2, 4, 5, 6. Okay, we're good on that one. Nitrogen is what, 5? 1, 2, 3, 4, 5. Okay, we're good on that one. And oxygen is 6. 2, 4, 5, 6. So that one right there is completely and totally neutral. And that's all you have to do. And like I said, what's great about this is everything that I'm showing you here, this 4, 5, 6, 7, 8, and these letters are on the periodic table, which should be in your classroom, which your professor allows you to take to every single exam because it sits there in the classroom. And you can use those numbers to figure out what the formal charges are going to be. Alrighty, my friends, with that, make sure to always like and subscribe so you don't miss any tips and tricks on acing your organic chemistry class. And until next time, I hope you all have a good one.